All right, it's time to get ready for our Unit 3 test. And so as we go through this, let me know if you have any questions or if there's anything else I can help you with. On the first one, it gives us 3 points of a parabola and asks for the equation. Anytime I have 3 points, I can go into my calculator and we're gonna press Stat, which is right here underneath Delete. We'll press Stat. We're gonna press Edit. And we're gonna put all our X's in L1, so -4, enter, 2, enter, and 8, enter. And then we'll put all our Y's in the L2, so -65, -17, and -185. And so now we'll quit it and go back into Stat. We'll go over to Calculate, and we're doing the quadratic. And so quad reg, and press enter all the way through. There's my A, my B, and my C. So Y equals -3x squared plus 2x minus 9. We'll do the same thing on number 2. We'll go back into Stat. I'll delete these numbers, and we'll put in our new one. So I've got -1, 3, and 8. 47, 91, 551. I'll go back into Stat, go to the right to quad reg, and there's my A, my B, and my C. So Y equals 9x squared minus 7x plus 31. All right, so anytime you're given 3 points, there's what you can do to find the equation of the quadratic that's given. And so on number 3, find the vertex of the following. You could do completing the square or do the -b over 2a to get the x. And so that's gonna be -8 over 2 times 2, which is -8 over 4, which is -2. And so that's the x value. And so now for the y value, I'll plug in that -2. And so -2 squared plus 8 times -2 plus 21. And so -2 squared is 4 times 2 is 8. That's -16 and plus 21. You could put this in the calculator, but that's gonna be -8 plus 21, which comes out to be 13. And I'll just check it real quick in my calculator to make sure I did it correctly, but I'll put -2 squared plus 8 times -2 plus 21, and I got 13, so that's it. All right, number 4, we'll do the same process, finding the vertex. And so -b over 2a will give me my x value. And so that's -4 over 2 times 1, which is -4 over 2, which again is -2. We'll take that -2 and plug it in to the x. And again, we could go into our calculator, but 4 minus 8 plus 12, that's -4 plus 12, which is 8. And just to make sure I got it, I'll put in my calculator just to make sure. We've got -2 squared plus 4 times -2 plus 12, 8, that checks. And so those are my vertex points for the equations. All right, so -b over 2a, that gets the x value, and then plug it in for the y. On number 5, there's a couple of different ways you can do this, but one way is to just plug in and see. And so I'll plug in the y value into the y, the x value into the x's, and see, is it a true statement? And so on the first one, -8 is less than or equal to, and I'll come over here to the side, or you can just go in our calculator. So I've got -3 times 2 squared plus 2 times 2 minus 1. That's -9. And I would see, is -8 less than or equal to -9? No, that's not a correct solution. This one's a little bit easier, having a 0. Those are going to cancel out, and leaving -1. Is -7 less than or equal to -1? Yes, that's a true statement. -2 less than or equal to, plugging in 1. I'll just do it in the calculator just to try and speed up a little bit. -3, and we're going to plug in 1, which doesn't change anything. But I'll put it in there, plus 2 times 1, minus 1, and we get negative 2. Is negative 2 less than or equal to negative 2? Yes, that's a correct solution as well. And then negative 33 less than or equal to, let's see, I'll just pull up the entry and we'll insert negative 3, negative 3, negative 34. And so is negative 33 less than or equal to negative 34? No, that's greater. And so it's not a correct solution. So B and C are true solutions. Another way you could do it, I'll go ahead and show you this as well, is I could go in my calculator and I'll put in the equation negative 3x squared plus 2x minus 1. I'm going to change my line to be less than, and so I'm going to do it like that, and I'll graph it. And so there's my graph, and now I could just move my little cursor to 2, negative 8 and see if it's inside the shaded region. And so, oops, let's go over here to the positive 2. So it's actually pretty close. So it may be easier to do it algebraically, but it seems like it's really close, but maybe right on the outside. It's also off by a little bit. But yeah, it's really close. And so this is one way you could try and do it, is just move around your cursor and see. So like 0, negative 7 is clearly inside the shaded region. 1, negative 2 is another one it's pretty close, and it should be close because it's right on the line. And so algebraically you can see it for sure. Graphically you can try that way as well. All right, x squared minus 3, this is vertex form or standard form, either of them. If you tried to do the negative b over 2a to get the x value, you're missing the b term, so it's negative 0 over negative 2, which is just 0. If I plug in 0, that's negative 3, that's my vertex, 1, 2, 3. This one does have a flip, so it's going down instead of up. So we're going to go over 1 and down 1. We'll go over 2 and down 4. Since there's no equals bar, this one's going to be a dotted parabola, a dashed parabola. And since it's greater than, we're going to shade above. So we're going to go above, and it's everything above that parabola. Number 7, to simplify, we want to distribute where we need to, combine like terms, and just make this a smaller expression. And so that's going to become 20i minus 8i squared minus 18 minus 3i minus 12. I have I squared right here, which we've gone over. Anytime you see I squared, that's equivalent to negative 1, which is going to change this to be a plus 8 instead of a minus 8. And now we'll just combine like terms. So I'll do my numbers first. I've got a positive 8, a negative 18, and a negative 12. I'll do my negatives first. Those two together make negative 30. Plus 8, we get negative 22. And then I've got 20i minus 3i, which is 17i. Solve for x. When we solve, that could be the factoring. And so I could try to factor and try and say, okay, what multiplies a 12 and adds to negative 3? Nope, that doesn't work. And so since factoring didn't work, we're going to go to the quadratic formula, which as a reminder is negative b plus or minus the square root of b squared minus 4ac all over 2a. And so we're going to have 3 plus or minus the square root of 9, that's the 3 squared, minus 4 times 2 times 6, all over 2 times my a, which is 2. And so I'll simplify that box first, and so I'll use my calculator, and I'll have 9 minus 4 times 2 times 6. And so I have 3 plus or minus the square root of negative 39 all over 4. Anytime I see a negative under the square root, I know I'm going to be pulling out an I. But I can also go out and see, okay, can I simplify the square root of 39? That's 3 and 13. That didn't go any lower. There's no pairs, and so the only thing I can pull out is an I. 3 plus or minus I, square root of 39 over 4. That's my answer. On number 9, we'll do the same thing. All right, what multiplies a 6 and adds to -4? I can't think of anything, so we're going to go into the quadratic formula. 4 plus or minus the square root of 16 minus 4 times 3 times 2 all over 2 times 3. And so underneath the square root, I have 16 minus 4 times 3 times 2, which gets -8. So 4 plus or minus the square root of -8 over 6. Square root of 8, I'm going to come out to the side and try to simplify. 8 is 2 times 4, which is 2 times 2. I've got a pair of 2's. So this is going to become 4 plus or minus. I've got the pair of 2's comes out on the outside. That negative brings the I on the outside. And I've got this lone 2 that goes back on the inside, all over 6. And then I'm going to see, okay, can I simplify these 3 numbers right here? Leave the number under the square root alone. And so this is going to become, let's see, I'll write the answer over here. 2 plus or minus, that becomes 1i square root of 2 all over 3. And that's my final answer on that one. All right, this one is just knowing what it's asking. It says how many solutions are in this graph. Solutions. Anytime you see that word solutions, it means the same thing as roots, zeros, x-intercepts. So basically it's asking how many times is it crossing the x-axis. There's one right here, and here's another right here. This one has 2 solutions. All right, now we're factoring the following. So this one should factor. And so I'm going to try and think, okay, what multiplies a -6 and adds to 5? That's going to be 6 and -1. I divide by my a of 2. And so this becomes 1x plus 3, 2x minus 1. Number 12, there was no GCF over here. I would have. On this one, there is a GCF. I can pull out a 2. So I'm going to divide everything by 2. Leaving me 16x squared minus 1. This is the difference of squares. The a squared minus b squared is equal to a plus b and a minus b. Take the square root of each item, plus and a minus. And so the 2 is going to stay in the front, and this is going to branch down to 4x plus 1 and 4x minus 1. On this one, I can take out 3x, and I'd be left with x plus 8, and it's done. I don't want a negative in the front, so I'm going to pull out the negative, and it's going to change all my signs. And now, what multiplies a 15 adds a -8, -5, -3, divide by my a of 5. So I'm going to have the negative in the front, x minus 1, 5x minus 3. On this one, I can divide by 4, and so I take out a 4, I'm left with x squared minus 2x minus 8. And so I'm going to try and think, okay, what multiplies a -8 and adds to -2? That's going to be a -4 and a positive 2. So I have the 4 in the front, x minus 4, x plus 2. There's no GCF on this one. I'm going to try and think what multiplies a -12 adds to 11. That's going to be 12 and -1. Divide by my a of 4. And I've got x plus 3, 4x minus 1. And then lastly, we're going to be graphing and listing all the attributes of these graphs as we do. This is in Vertex form. I don't need to do anything with it. That's going left 6, so -6. Up 8, so positive 8. So we're going to start at -6. 1, 2, 3, 4, 5, 6. Go up to 8. So there's my vertex. And so this one has a reflection and a stretch by 2. Sorry, a reflection and a stretch by 2. And so we're going to go down instead of up, and we're going to stretch by 2. So we're going to go over 1 and down 2, over 2 and down 8. And so there's my parabola. My axis of symmetry is where it cuts the parabola in half, which should match your vertex. And so x equals -6. This one has a maximum value of 8, has a domain of all real numbers. My range goes from -infinity all the way up to 8. And the roots are 1, 2, 3, 4, 5, 6, 7, and 8. 4 and 8. On this one, I can already see the roots. We've got 3 and -1. By setting these equal to 0, it gives me my 2 roots. And so I've got -1 and +3. I can't see the vertex, and so the first thing I'm going to do is FOIL these, do the distribution. And so negative, and so that's going to be x squared plus x minus 3x minus 3. X squared minus 2x minus 3. And then we'll distribute that negative x squared plus 2x plus 3. And so now I'll do the -b over 2a. And so I've got -2 over 2 times -1. -2 over -2, which is 1. And I'll plug in that 1. It doesn't matter where I plug it in. I can plug it into any one of these. I'll go ahead and just plug it down here because it's pretty easy with a 1. And so we're going to have -1 squared, which is 1, plus 2 times 1, which is 2, plus 3. And so that becomes 1 plus 3, which is 4. This one does have a reflection over the x-axis, and so we're going to be going down instead of up. Over 1, down 1. Over 2, down 4. And there's my parabola. X equals 1. It has a maximum value of 4. All real numbers every time. -infinity is the lowest point all the way up to that 4. And then our last problem. Vertex, I could do -b over 2a, which would be -4 over 2 times 2, -4 over 4, which is -1. And so 2 times -1 squared is just 1, so that's good, plus 4 times -1 is going to be -4, so that's actually going to be a -2. So -1, -2. And then this one has a stretch by 2, a vertical stretch by 2. So instead of going up 1, we're going to go up 2. Right 1 and up 2. Right 2 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. And same point over here. And so here's my parabola. So x equals -1. This one has a minimum value of -2. All real numbers again. Has a low point of -2 all the way up to infinity. And my roots are 0 and -2. And that completes the review. I hope everything made sense. If you have any questions, make sure to let me know before our test on Thursday. Hope you have a great day.